In this episode, we focus on one of the most practical ideas in a security operations center, SOC, the use case, which is a clear description of something you want to detect, why you want to detect it, and how you will recognize it using the signals you have. Beginners often hear the term use case and assume it means a feature request or a vague security goal, but in security operations, it is closer to a promise. If certain behavior happens, the SOC will notice it in a meaningful way. The quality of your use cases shapes the quality of your alerts, because alerts are not magic. They are the result of deciding what matters and then building a pattern that reliably points to it. When use cases are rushed, they become noisy, unclear, and inconsistent, and analysts lose confidence because every alert feels like a coin flip. When use cases are built carefully, they raise detection fidelity, meaning a higher proportion of alerts represent real security-relevant activity, and they also raise analyst confidence because the team understands what the alert means and what to do next. Our goal is to explain how to think about use cases at a beginner level, how to build them so they improve decisions rather than create churn, and how to connect them to evidence and action without becoming tool-specific or implementation-heavy. A solid use case begins with a clear security story, because detection is always about behavior over time, not about isolated trivia. The story has 3 parts: what could be happening, why it matters, and what it would look like if it were happening in your environment. For example, an account might be misused, a device might be infected, or sensitive data might be accessed in an unusual way. The why matters because it determines severity and urgency, and it prevents the team from treating everything as equally critical. The what it looks like part matters because it forces you to think about observable signals rather than feelings. Beginners sometimes start with a signal and then try to invent a meaning for it, which is backwards, because you end up detecting what is easy instead of what is important. When you start with the story, you can then ask whether you have the evidence to detect it with reasonable confidence. If you cannot observe it, the use case might need different signals, a different scope, or a different goal, and that is a normal part of building mature operations. Once the story is clear, the next step is to define the behavior you care about in a way that is specific enough to detect, but broad enough to catch real variations. This is where beginners often struggle, because they want a simple rule that always works, but attackers and systems do not behave in perfectly predictable ways. A use case that is too broad triggers constantly and becomes noise, while a use case that is too narrow triggers rarely and misses real threats. You can think of this as designing a net. If the holes are too large, important things slip through, and if the net is too tight, it catches everything, including harmless debris. A good use case describes the behavior using categories, such as unusual authentication patterns, unexpected privilege changes, suspicious process activity, or strange network connections, rather than relying on one brittle detail. It also includes boundaries, like which systems matter most or which accounts deserve extra attention, because not every event has the same risk. This step is about balancing sensitivity and precision intentionally instead of discovering that balance accidentally after analysts have been overwhelmed. A key idea tied to detection fidelity is that a use case must be built on reliable data, and reliable data means signals that are consistent, timely, and meaningful. If an alert is driven by signals that are missing for half of your systems, or delayed by hours, or interpreted differently depending on source, analysts will not trust it. Beginners should understand that data quality is not a purely technical detail, because it directly affects decision quality and operational stress. A use case should clearly state what data sources it relies on, not in a product sense, but in a conceptual sense, like authentication records, endpoint activity records, or network flow records. It should also state what minimum information is required to make a decision, such as the identity involved, the system involved, the time window, and the observed action. If those basics are missing, the alert will become a guessing game, and guessing games produce inconsistent escalations. When you build use cases with data reliability in mind, you protect analyst confidence because the alert arrives with enough context to start a meaningful investigation. Another foundation is to define the expected outcome of the alert, because an alert without a planned outcome is just a notification. A use case should answer what decision the analyst is supposed to make and what the likely next step is if the behavior is confirmed. That does not mean you are writing a step-by-step procedure. but you are clarifying intent, such as verify legitimacy, contain a device, or escalate to incident coordination. Beginners often think the job is to make alerts, but the real job is to make decisions easier and more consistent. If the only outcome is close the ticket, then the use case is not improving security. It is only generating activity. A strong use case reduces uncertainty by pointing to a specific risk and by providing evidence that helps an analyst confirm or reject that risk. It also sets expectations about urgency, so analysts are not forced to guess whether the situation is routine or critical. When outcomes are clear, analysts feel more confident because they know what success looks like for that alert. A practical way to improve fidelity is to include context and correlation, which means combining signals so the alert represents a pattern rather than a single event. A single event can be misleading because systems are noisy and legitimate actions can look strange in isolation. When you correlate, you connect related observations, such as repeated authentication failures followed by a success, or a privilege change followed by unusual access. Correlation does not need to be complex to be useful, because even simple time window patterns can dramatically reduce false positives. For beginners, the key is to recognize that a use case is not necessarily a one-line rule. It is a description of a behavior pattern that you can observe. Adding context also means including information about normal behavior, like typical locations for users or typical activity for certain systems, because abnormality is often defined relative to a baseline. If you cannot define any baseline, you can still build a use case around high-risk actions that should be rare, such as certain privilege changes. But you should be aware that even high-risk actions can be legitimate. Correlation and context turn alerts into narratives, and narratives are easier to validate than isolated facts. Analyst confidence is heavily influenced by how well use cases are documented and communicated, because the alert must make sense to the person receiving it. If the use case is written in vague language like suspicious activity detected, analysts will learn to ignore it because it does not tell them what is suspicious. A strong use case includes a plain language description of what it is trying to catch, why it matters, and what evidence supports the alert. It also includes common false positive reasons, because naming predictable benign causes saves time and reduces frustration. Beginners should not underestimate how much confidence comes from knowing that someone has already thought through the likely explanations. This is also why consistent naming and categorization matters, because analysts build mental models over time, and messy naming breaks those models. When use cases are documented clearly, you reduce the cognitive load on analysts, meaning they spend less mental effort decoding the alert and more effort validating the risk. That shift is a major part of moving from a noisy SOC to an effective one. It also helps to build use cases in layers, starting with high-value, high-confidence detections and expanding carefully, because trying to detect everything at once creates noise and discouragement. High-confidence detections often involve actions that are inherently risky or rare, such as unexpected privilege assignment, suspicious changes to security settings, or access to highly sensitive resources from unusual contexts. The beginner trap is to start with broad activity like unusual network traffic without a clear risk story, which tends to generate large volumes of ambiguous alerts. A layered approach means you begin with detections that are easier to validate and more likely to represent real issues, and then you refine and add more nuanced detections as your understanding grows. This approach builds analyst confidence because early wins teach the team what good alerts look like. It also builds organizational trust because stakeholders see that escalations are meaningful and supported by evidence. Over time, as the team gets better at tuning and correlation, you can move into more subtle behaviors that require more context. Layering is not about being timid. It is about building a stable foundation before adding complexity. A major misconception is that more use cases automatically mean better security, but quantity is not the goal, because an SOC can be overwhelmed by a large library of mediocre detections. Each use case adds operational cost because it creates alerts, triage time, investigation time, and tuning work. If a use case does not produce meaningful detections or does not lead to useful decisions, it is not just neutral, it is harmful because it consumes attention that could be spent on better work. Beginners should recognize that attention is a limited resource, and security operations is largely the art of directing attention effectively. Another misconception is that a use case is finished once it is created, but use cases should be treated as living assets that must be reviewed and improved as the environment changes. New systems, new workflows, and new threat patterns can all change whether a use case is accurate. If you never revisit use cases, fidelity decays, and analysts lose confidence as alerts become less relevant. Good SOC teams treat use case maintenance as part of normal operations, not as a special project. Testing and tuning are where detection fidelity is won or lost, and even at a beginner level you can understand the logic of iterative improvement. When a use case first goes live, you should expect some false positives, because you are learning how the detection behaves in your environment. The key is to capture what happened, identify the reason the alert fired, and decide whether that reason indicates a real risk or a normal activity that should be excluded. Over time, tuning reduces repeated false positives and improves the signal-to-noise ratio, which directly improves analyst confidence. It is also important to check for false negatives, meaning situations where the behavior happened but the alert did not fire, because that reveals gaps in logic or missing data. Beginners may think tuning is just making alerts quieter, but the true goal is making them more accurate, which can sometimes mean adding alerts in one area while reducing them in another. Tuning should be guided by clear feedback from analysts, because analysts see firsthand which alerts help and which alerts waste time. When analysts feel heard and see improvements, confidence rises, because the system proves that it can learn. Use cases should also be connected to escalation and response expectations, because detection without a response plan can create confusion and delay. Each use case should have a clear severity philosophy, meaning what makes it low, medium, or high, and what conditions change that classification. This prevents the common problem where the same alert is treated as urgent by one analyst and routine by another. It should also specify who needs to be informed when the use case triggers in a serious way, because some risks require coordination beyond the SOC. Beginners should recognize that response is not always about dramatic containment actions, because sometimes the right response is investigation, confirmation, and targeted communication. Still, without a shared understanding of what the use case implies, the SOC cannot respond consistently. This is why use cases and escalation paths should evolve together, because the alert should naturally lead to the next decision. When these pieces align, the SOC becomes smoother, and analysts feel more confident because each step makes sense and fits the bigger process. When you step back, building use cases is one of the most direct ways an SOC improves both detection fidelity and analyst confidence at the same time. A well-built use case starts with a clear security story, defines observable behavior with the right balance of breadth and specificity, and relies on reliable data with enough context to support a confident decision. It connects the alert to a meaningful outcome, uses correlation to reduce noise, and documents intent and common false positives so analysts can work efficiently. It grows in layers, prioritizing high-value detections first, and it is treated as a living asset that is tuned and reviewed as the environment changes. It also fits into escalation and response expectations so the alert leads naturally to action rather than confusion. For a beginner, the most important idea is that an alert is not valuable because it exists. It is valuable because it reliably points to a real risk and helps a person make a better decision. When use cases are built with that mindset, the SOC becomes less about chasing tickets and more about building a trustworthy detection and response capability that improves over time.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.